Hello, this is Mr. Muller for lesson 12-7, solving rational equations. Alright, so for this we're going to use a lot of the cross-multiplying or butterfly method. So some of these will just be a couple steps with solving with the butterfly or cross-multiplying method, and some of the problems we're going to have to get ready, or get the problem ready to solve with the butterfly or cross-multiplying method. So problems like this, hopefully remember the butterfly or cross-multiplying, whatever you called it. So I'm going to multiply 6 times b here and 4 times b plus 4 here. So then I would really end up with 6 times b is 6b, and then 4 times b plus 4 is 4b plus 16. And then I would need to subtract 4b from each side. So minus 4b minus 4b. So I end up with 2b equals 16. So then b would equal 8. Okay. So those are, the level 1 kind of problems going in right away. We could probably solve those. It does get a little bit harder with problems like this, where our denominators are both the same, but we have one step before we can cross multiply. So for a problem like this, I have 9 over c minus 8 over c equals 1/4. Well, I would just simplify here. So 9 minus 8 is 1 over c equals 1 over 4. So then I'm going to end up just cross multiplying 1 times 4 and 1 times c. So I have 4 equals c. Remember, these are all the same, so some of you just saw right there where it's like, 1 over c equals 1 over 4. Well, obviously the c has to be 4 because 1 over 4 equals 1 over 4. You could do it that way as well. Problems like this, so not as simple to get the terms alike. 2 different ways to do this one. So I could multiply this whole bottom by n plus 1. That's going to result in some not so nice issues. So what I would do is subtract the 3 minus n and bring it over to this side. So if I subtract 3 minus n, so I'm bringing it over here, so I have 3 over n over here. Well, now it's a lot easier to make my denominators common, because I just need to end up multiplying this by 2 now. So now I'm left with 2 over n plus 1 equals, so 9 minus 2n, and now since I multiply that other fraction by 2, I end up with 6 over 2n. And now it really just looks like this problem that we just did on the left, where I'm going to end up simplifying. Well, 9 minus 6 is 3, so then I'm going to end up cross-multiplying the 2 over n plus 1 over equals 3 over 2n. So let's solve this one, and I'll kind of show you how they end up being pretty much the same, or how we can go back and check it. So I have n plus 1 here equals, this is 3 over 2n. Okay, so I have 4n once I cross multiply. There's my 4n right there, 2 times 2n. And if I multiply this, I have 3n plus 3. Okay, subtract 3n from both sides, so I'm left with n equals 3. So kind of important, we figured out n was 3. So now let's remember that n is 3, and this is algebra, so we can go back and check our work for a problem like this. So if I think n is 3, let's plug it into these problems and see if that works. So I end up with 2 over 3 plus 1, which is 4. So I have 2 over 4 plus 3 over 3, which is really just going to be 1 then, because n is 3, equals 2 times n, and we figured out n was 3, so 2 times n, so 2 times 3 is 6, so 9 over 6. Is this true? 2 over 4 plus 1, so 1/2, plus 1 is 1 1/2. 9 over 6, if I simplify that, is 1.5. So you can always go back and double check these to make sure that you are doing it correctly, so you don't just keep going. Again, here's one where I would simplify here, multiply this side by 2 so that my denominators are the same. Here's another one where I'd probably subtract over here first, so then I would do 9 minus 3, and then I would have x over 2 on the same side. So the book will try to trick you with some of these problems, make them a little harder than what they need to be, but that's probably as hard as it's going to get when you have to subtract to one side to figure out which side it's going to be easier for you to make the denominators common.